So in this example, we're giving a simple circuit, and they've identified 2 points, which is point 1 and point 2, and they've asked us to use circuit analysis techniques and determine what the voltage difference between those 2 points are. So we should be able to do this by just traveling from one point to the other in the circuit and adding up the voltages and voltage drops along the way. So there are 2 different ways we can go. We could come this direction, going from 1 to 2 and adding those voltages up, or we could go this direction, same thing, adding up and subtracting the voltages as needed. So let's do that, and we'll actually do it for both paths to show that that should work. So for the first one, like I said, we're going to take this path here, and we're going to start at 1, go around the circle, end up at 2. So for that one, we'll say that they'll call this V12, so it's the voltage between point 1 and 2. And let's start adding up the voltages here. So the first thing we encounter coming this direction is this voltage source, and we see we hit the negative side of that source first, so then that will be a minus 7 volts. So then we continue down this path, and when we do, we come to this resistor. Now we see the current here is given to us as traveling clockwise around the loop. So when it gets up to this point, the current's actually flowing that way. So it's against our direction that we're traveling. So again, that's going to be a negative. And we're going to use Ohm's law, which we would call is just V is equal to IR. So we have the resistance R and we have the current I. And so that will just be the current, which is 2 amps. Oh, excuse me. So this will be minus 2 times 8 ohms. So it's 2 amps times 8 ohms. So now we continue down our path, and now we come into this voltage source, and we see we encounter the positive terminal first. So then this will be a plus 24 volts. And after that, we don't run into anything else until we get to our second point. So that being the case, we should be able to simplify this, and what we'll have is a minus 7 minus 16 plus 24, and then that's going to equal 24 minus 23, and that is equal to 1 volt. So we're calculating, if we go along the red path, that the potential difference between 1 and 2 will be 1 volt. Like I said, though, there is another way we could go, and we can travel around the loop this direction, going from 1 to 2. And let's see what we come up with if we do that. So in this case, we'll have V from 1 to 2. And we'll come along. The first thing we encounter is this resistor here. Now the same current we see traveling here clockwise, now we see it's going in the same direction as we're traveling. So then this will be positive. So again, it's just V equal IR. So I is the current, which is 2, and the resistance is 6. So that's the first device. Now we continue around, and then we encounter this voltage source here, and we encounter the negative terminal first. So then that'll be a minus 15 volts. And then finally, as we come around, right before we get to our point, we come in contact with this 2 ohm resistor, again in the same direction as the current flow. So that'll be a positive. So then that will be plus 2 amps times 2 ohms. So if we simplify this out, that's going to be 12 minus 15 plus 4, or 16 minus 15, and we come up with 1 volt. So it doesn't matter which path we pick, we get the same results. So that means that the voltage difference between point 1 and point 2, if we were to put a meter there, we should measure 1 volt.